everybody. I'm Philipp Stiefel, and I work with Access and VBA for about 20 years now. And for almost as long, I think about how I can improve my work, how I can optimize processes, how I can use new methodologies, new techniques to improve the code I write, to improve my efficiency, and to improve the software I create. So with this background, I'm here today to talk about software quality, modern software quality with Access and VBA. Originally, I wanted to start my presentation with a couple of anecdotes from customers, IT administrators, other developers, people in the IT industry speaking derogatively about Access and VBA. But I changed my mind because last month something was published that gives you a much broader view about the problem. And excuse me for a second, I forgot to get my thingy here. VBA has been voted the most dreaded language of them all. That is the Stack Overflow Programmer Survey for 2019. And, well, that is an achievement. It impressively shows a lot of people know VBA, but they're not particularly fond of it. So I can only guess what the reasons for that result are. Pretty obvious is the VBA environment and the VBA language, which has not been updated for more than a decade now, at least not significantly. That is certainly affecting this result significantly, and there's not much we can do about it. Another factor is surely that VBA is an entry-level language that is used by power users who are not really programmers and by beginners in programming. And that many people just record macros and the output is VBA, and then somebody looks at it and that's horrible stuff programmed there, but it's just a recorded macro. And that is a good thing.
Which you can't do in Access.
Yeah, you can't do that in Access, but VBA in general.
Yeah.
Yeah. So that is actually a good thing that there is a low bar of entry to Access. That's good, and we can't do much about those people having little knowledge when they start. But I think there's also a third factor in that. I've seen many huge projects who were created by professional developers, and they had poor code quality and were hard to understand, hard to maintain, and that is basically the area here I'm going to focus on, how to improve on that. So, before we get really started, just a short idea what software quality is, what is in the industry. It's a term that has been used by the International Standards Organization to create the standard ISO 9126 in 1991. And amongst other areas, it covers the area of maintainability. And they focus on analyzability. Is it possible to understand how a program works and what it does? Changeability. Can I change bits of a program easily? And is the program stable? That, like, if I do a little change, the rest should not fall apart. And testability. Can I verify that the program works as intended? So what effects does that have for us or for any developer working with our projects? Immediate effects of high and good code quality are clear and unambiguous code. You know what you're reading, you don't need to think about what is the person talking about or writing about in the code. It's easy to understand. And it's easy to test. You can verify, does it work or does it not? And then it's obviously easy to change. And the end result in the developer sphere is you have a product that has fewer errors. And the indirect effects that leads to are less development time long term. Yes, if you have a very small project that you're working on for 2 or 3 days, pushing it out to the customer, and they are using that in a very limited area with 1 or 2 users, and that is superseded by another application in a couple of months and stuff, yeah, maybe you get away with lower quality, that's just a quick fix. But on the other hand, these projects tend to come back. They live longer than you expected, they kind of spread throughout the company, and a year later that temporary solution for a single user has become a critical application for a whole small or mid-sized company. So even then you should not ignore code quality. And if you have less development time, your customer has to spend less money. And that is an obvious advantage for your customer. But it does not mean that you are getting less money, because if the client is happy with the project, he will kind of give you more work and he will extend the project, and there will be in the end more work for you, and you will be able to charge more money for your work. So you benefit as well from good code quality. So, just to preemptively answer a question I frequently get, is this whole topic relevant for the single developer? Well, yes, code you have not touched in a while could have as well been written by somebody else. That is a quote. I unfortunately was not able to find out the source of that quote, but I like it really much because I can absolutely confirm it is true. And the other aspect is, if you set yourself standards and write them down or whatever, kind of fix them, you are holding yourself accountable. It's not as easy to just do a quick thing and nobody sees it and I don't care. And if you know you're violating your own standards, then being a bit harder to do sloppy work there. So how translates all that into our work? By coding conventions. I'm not really going to talk about the basics like option explicit and typed variables and indented code. That's basics. I hope all you do that. But what I'm going to dig in a little bit are naming conventions, clean code, and commenting code. Oh, excuse me for a second. I just forgot an urgent fix I need to check in. Here's a bug lurking and I need to change that. And I need to check that in to production, and not to production, but I need to check that in because it's really an urgent fix. So, and yeah, I'm sorry you had to see the code. I promise I'll fix that later, yes? Okay, where were we? Yes, naming conventions. That is the first that comes to mind when talking about coding conventions. And I guess all of you who does not know the Hungarian notation and the Lesinski-Redick adaptation of it for VBA? Nobody. Who actually uses this? Oh, quite a lot. More than half, I guess. Okay, so this seems to be a common standard that many of you use. But how much does this really help? Let's do a quick excursion into the history of Hungarian notation. It originally started when Charles Simony, an Hungarian, hence the name, invented a naming scheme for variables. And he thought, yeah, well, it would help in code if we incorporate the logical type of a variable into its name. And if you are working with the Windows VBA, you see this quite a lot. There are abbreviations like HWND for a window handle, or CB for a count of bytes, or in the original specification there was US for unsafe string. In the API we see a lot of LPSTR stuff for pointers to arrays of chars, which are in our understanding strings. And this leads to this being obviously a little bit fishy. I've got a HWND something, a window handle, and it's assigned a CB something else, a count of bytes. That looks fishy. That is probably not going to end well if I do that in code. So this helps to spot errors when looking at code. But if we look at the VBA declaration, both types are long. So, considering Lisinski and Reddick, we would have to do this. We are kind of watering down the Hungarian notation, and there's actually a term for that. It's System Hungarian's notation, and it takes the technical type of the variable as a prefix. So it's LNG for our long. And if we look at LNG something assigned by LNG something else, that doesn't look too bad, does it? Okay, you might say that is my fault because I did use very ambiguous name with something and something else. So let's change that. LNG main window handle is assigned LNG buffer size. Now that looks bad again. You see, this is probably not right. Okay, problem fixed. But let's take the Hungarian notation out of the equation. And we've got this. And it's still looking fishy here. We still see the problem immediately, and we got rid of a bit of cruft with our variable name prefixes there. So, Hungarian notation is, in my opinion, not a real core benefit of naming conventions. If you use it, I'm not telling you to stop or so, but it's not that helpful as many people say, because, well, it does not make such a difference. What makes more difference, in my opinion, is language. And I'm not talking about the programming language, but about human language. You should think about which languages do you use in your projects. And I originally thought, yeah, everybody should only use English. But I was at a user group meeting where we discussed code quality and this particular thing, and many people were from Germany, and they told me, yeah, that is going to be a bit of a problem because we're not so familiar and proficient with English, and we have a hard time figuring out the proper English names, and we might make mistakes there and need to look things up in a dictionary, find the wrong terms. So maybe just making English compulsory is not the best idea, but if you use your local language or other languages, you should say, yeah, you can use English terms and German, but nothing else, because otherwise if you have a French developer, then he will use French terms, and maybe there's someone from China and he is using Chinese terms, and then that is going to be a problem. So you should say, yeah, we are allowing this language and maybe this else, but no other human languages. Another point is terminology in a project. I work in for a financial services company, and they deal with loans. And some people in the company call the loans accounts. So depending on who you talk to, you will say, yeah, I need to enter the ID or the number of the loan, and then it should pull up the loan details, and the developer listening to that will say dim loan ID as long and start to code. But other people talk to other people and they say, yeah, it's all about an account, and someone else is saying, Tim, account ID, and yeah, essentially it's both meaning the same thing. So you need to go through the terminology and say, yeah, we are using the term account and not alone. And there are lots of other areas where you need to kind of define the project language inside your code, the terms you are using, that not one day you use this term and the other that, and you essentially mean the same thing, because that is going to be confusing. Word separators, just a tiny bit. You can use camel case, like putting an uppercase letter at the beginning of words and no spacing in between, or you could use underscores. And I'm not telling you one is better than the other, but you should define a standard what you do and kind of use that throughout the project. And be careful with abbreviations. You might think, yeah, the ABC thing, everybody in the project knows what ABC is, and you write get ABC, and then a new programmer comes along and, you know, what is ABC? I've never heard that term. So if you use acronyms and abbreviations, only use them if you can assume anyone who is familiar with VBA programming does know the term, or anyone who has had a brief introduction in the problem domain does know the term as well. And beyond that, do not use abbreviations, because they will create questions. And in the end, it all boils down to creating and using meaningful and pronounceable names. That is the essence here, meaningful. So,
I think one point is important, that if you use things like ID that you define either at the beginning or at the end, and that you define that.
Pardon? I did not exactly get that. When you use ID, what?
The term ID.
Yes.
If you say ID number or number underline ID, meaning the same, and the one creates the word field underline ID, and the next one creates ID underline field.
Yeah, okay, yeah. That is indeed an interesting aspect, and I cut that out because I'm a bit short on time. I would say if it is about a customer ID, you shouldn't write ID.customer, because you will probably have like 20 different ID thingies and they all start with ID. So I would say customer ID, account ID, order ID, whatever, the more meaningful term first. But now that we have got a naming convention, we should use it. Use it to name things in our code. An operation like 2 or 3 lines of code that are belonging together and do something together should become a method. And the method is the name, the method name is the name for that operation. And if they produce a result, that result is stored in a variable, and thus the result is named. And if we have constants in our application that we use anywhere, then we should name them as a constant and not just write down the value into the code. And if we have a defined set of options, we should create an enum for these options. And I brought a little sample here. Please don't look at the spaces in the name. It's taken from Northwind. That is not what this is about. But beyond that, I've got a lot of code, and it's working. It's compiling. It's doing what it's supposed to do. But it is not easy to figure out what exactly it is supposed to do. But now I name things. The functionality is identical as it was before, but I removed operations and put them into their own methods. I replaced magic numbers with constants or enum options, and now you can actually read it. If not order is invoiced, then message box OK only, cannot ship not invoiced. Else if orders shipped, then message box OK only, cannot ship order, shipped already. Else if not validate shipping info, then message box OK. You get what I mean. You can read it. It's like a text. And I did not change the code. I just put in names there, the things that are actually referenced there. And that is a transition to clean code. Clean code is simple and direct. Clean code reads like well-written prose. Clean code never obscures the designer's intent, but rather is full of crisp abstractions and straightforward lines of control. That is a quote by Grady Booch. And it is kind of the first time the term clean code was used with this intent, and that is what Robert C. Martin built upon with his clean code book. And he kind of created a bit of a philosophy. So I think clean code is something that every developer should at least have heard about, and I highly recommend reading the book. The basics of clean code are follow the standard. So in the first place, you need to have a standard. So we are back at the coding convention. Then simpler is always better. Get rid of unnecessary complexity. And the Boy Scout rule, leave the playground cleaner than you found it. And our playground is the code, of course. That is, these rules apply generally everywhere. And a little bit more directed to code, there are a couple of more code-directed rules. Dry, don't repeat yourself, avoid redundancy. Don't copy and paste things all over your application. Create methods that couple that, wrap that and call these methods. Limit dependencies and couplings. In Access, we have a tendency to do the stuff with forms, bang, some form name, dot controls, subform, whatever, dot controls, control name, dot value, and creating such a chain of dependencies. And that is something you should try to avoid, because you not only depend on one form, you depend on a form, a control, another form in that, and hence another control in there. Try to reduce these dependencies. Rather depend on abstractions instead of concretizations. That is a little bit difficult in Access because it sometimes requires interfaces or later bound references and stuff. But even though it's not easy and not so straightforward in Access, it's still better than having that huge chain of dependencies that will break once you change any bit in that chain. So, regarding to methods, our procedures and functions, there are a couple of suggestions in the clean code rules. They should be small, and there is not an exact measurement, but if the method's longer than you can see on a screen without scrolling, it is most likely too long. It should do one thing only, and that implies it has no side effects. If you have a method that says update order, it should not kind of send an email to whatever. It should update the order, do one thing. It should have as few arguments as possible, and it should have no flag arguments changing the behavior of a function. And that is something I had a hard time understanding at first, because I thought, yeah, well, my arguments to a function, of course, I pass arguments to a function to change its behavior. That is the purpose of the argument, isn't it? And that's not what it's meant here. And just to visualize this point, I created a bit of sample code. And something interestingly happened, but I'm talking about that later. I've got a method calculate. It takes an arg1 and an arg2, both are double, and a calc type, a calculation type. And when just seeing the declaration, you have no idea what that method is actually calculating. only when you look at the code you see, yes, the calculation type is addition, subtraction, multiplication, that is basic math. And depending what the calculation type is that is passed into that function, it will do an addition and subtraction, whatever, it will do totally different things. So this is clearly an argument that is changing the function's behavior. And now I rewrote the stuff according to the clean code methodologies to remove this argument that is changing a function's behavior. And now I've got 4 methods. It's just add, subtract, multiply and divide. And I've got parameter names like minuend, dividend, multiplier that are meaningful instead of arg1 and arg2. And now it is clear what is meant, and I created that to explain the additional argument, but it just happened, this illustrates all the items before. I have clear names, I've got methods that do one thing only. I got rid of a parameter in each method. And actually, the 4 methods combined together are shorter in lines of code than the long method before. So that sample already illustrates lots of the aspects of clean code, although I had not intended that in this case. Now let's look at classes. Always keep in mind, forms are classes and reports are classes. Not only if you create an own class module, you've got quite a few classes in Access. They should be small and they should do or be one thing only, once again. Well, that is a little bit harder to judge here, but if you see, yeah, this form is displaying this and that, and our class is doing different things, then it's something that should be reconsidered maybe. But most importantly, they should hide their internals. Unless you are designing a public API like the Access object model, you should prevent your users from doing forms, bang, name, la 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 la, as I explained earlier. That should not even be possible when you design the class, so that you hide all these internals away and just make the stuff available that should be used by clients of that class. There are quite a few more suggestions for classes in the clean code stuff, in the clean code book, but I don't talk about that because in Access we are rather limited with classes, so it does not really apply to us. But if you work in another language like VB.NET or C# or Java, read all about the classes. There's lots of interesting and useful stuff. Comments. Comments are important to, yes?
Oh, I thought you were asking for comments.
No, I'm sorry.
Well, I've got one, since you mentioned the word separators and in the interface classes in Libé. From my experience, if you use underscore in function or property names in an interface class, they will not work when you try to implement them. They will not appear on the drop-down list and it will not compile.
Oh,
so
great. I did not know that. That is an important thing. Okay, but now I'm kind of focusing on comments in code. Comments are good. They are explaining things, aren't they? Well, comments are a bit of a pet peeve of mine, and I think comments are statements waiting to become lies. And I gathered just a few examples. I threw most of them out because the time does not allow to show many, but here's just one. And these comments, these are from real applications. They are written by real developers, by experienced developers. Some of them have more experience than I do. So this is not any fake stuff. Well, a section for code area, private methods. Well, the next one is public sub init form, public sub filter form. Well, not so private anymore. And this one, that's a pet peeve of mine. And there's a tiny procedure header, not really one, get command. That is supposed to execute a stored procedure, so the name is not very good. The method name is get command, and there is an argument sp as string. Yeah, well, and the developer got the idea, yeah, sp is not very understandable, what should that be? And then he added a comment, sp : stored procedure name. And I do not get it why people do that, but I see it a lot. But why don't they simply change the name of the argument into stored procedure name? Then you would see it in IntelliSense when you try to call that method. You would see it in the object catalog. But this comment, you only see it if you actually look at the method, because you have no idea what it does or what that name means. So, I don't understand this. But anyway, the procedure header, that's something I see often too. We got a procedure here, and the procedure header repeats its name. Why? The name is already in the procedure. Then there is the author and the date it was written, and I kind of blurred the name to protect the guilty.
Why?
Yeah. Well, I'm not sure how does it help understand the code to see when it was written and by whom? Not sure about that, and it does not really get updated, because I can assure you that a function or method was written on August 1st, 2016, but it was changed a lot after. Well, then the purpose, explaining the purpose is good, isn't it? Well, let's look at it. This is about the ComboBox entity contact, and it's the after update event handler. So the purpose is update SubO2 company data in ACE code after update of entity contact. That does help a lot, doesn't it? Would never have thought that. Yeah, well, but what is update SubO2 company data? It's not really an explanation what exactly that is, but it's just repeating the lines of code. And then, and NACE code. I don't see anything about the NACE code in the actual code, and that is because it's not there anymore. So the purpose is totally useless or wrong. So what about commenting code? Module and procedure headers? No, I don't think so. They are quickly out of date and contain lots of irrelevant information, and you have to look closely to find the bits that are relevant and hope they are still correct. If you want to track this information, who changed what, use source control. I'm going to say a word on that later. What about explaining code that is hard to read and understand? That certainly is a good thing, isn't it? Maybe. Most of the time it is not. Rather, make the code easy to read and easy to understand instead of writing a comment. That's much better, isn't it? So, when we are writing comments, we should add comments that explain the intent we had when writing the code, if it's not possible to put that in the code itself, and to clarify code. And as a rule of thumb, I would say comment on why you are doing something, not what. The what is in the code. Only in the really, really rare circumstances that the what is not clear for whatever reason and you absolutely cannot fix it, then maybe comment on the what. But otherwise, always focus on the why. And I tried to find an example where some comment was good, in my opinion. And I had a hard time finding one, but I did find one. Just a very quick explanation. This is 2 lines of code reading data from an Excel sheet. And the first line is including the header in the data. And the second line is using a SQL command filtering out the header that we just included deliberately. So this seems ridiculous at first, and someone might look at it and say, yeah, we can simplify that and get rid of that first column header name, which is an additional argument to the method. We can simplify that, but no. We are doing it intentionally to force all columns to be of type text. Otherwise, automatic data type detection will cause errors with misdetected types. That is a useful comment because you cannot see that in the code and you cannot really make it obvious from the code. So, all I was talking up until now were rules where you need apply some sense of own human justice to verify are they met, are they not met, what should be the rules. You can also define a couple of technical rules, like for the declaration, you need to include option explicit, obviously, you need to have access modifiers like public and private, you have variable types and stuff. Your code should probably not contain any stop or end statement, and as far as I'm concerned, I do not want any of my projects contain stuff like do menu item or send keys, DDE stuff, and usually not run command, because there are better options to do that. So these are kind of prohibited terms in my projects which I work on. And there are a couple of tools that do help you finding these type of issues. There are the rubber duck inspections. MZTools has the review quality feature. Who of you knows review quality in MZTools? 2, 3, 4, 5, 6. Not too many. And there's Total Access Analyzer, which does similar stuff. Okay, quick demo here. Got a VBA project. It's derived from Northwind, so there is a bit of stuff in here. I have installed the RubberDuck VBA add-in. That is open source, totally free, and it has a feature code inspections. And I need to click the refresh button. You will go see bunnies or duckies going in a circle. And now it completed and it found stuff. And I rather group that by severity. Here are errors. Return value for member get orders is never assigned. There are a lot of these errors in here. And other stuff. Let's look at it. We can do a double click on that and then we'll jump to it. And right, here's a function that's not doing anything and it has no return value. And I wrote that to show something else, so it was intentionally here, but the code inspections of RubberDuck pointed that out. That is something that is probably not going according to plan if you run that code. So have we another interesting stuff. Option explicit, not specified. So that is interesting stuff as well. And I'm not going into too much detail. There are other areas in here, and you see it has a bit of a delay and stuff. And Northwind is a very small project. RubberDuck has really good ideas, but it's having a bit of a performance issue still. I reported a couple of bugs regarding that, and the RubberDuck team, they promised they're going to look into it, but it's not really there yet. But keep this name in your mind, RubberDuck. It's really a great project. But I'm going to show you review quality in MZTools, because that is what I use myself, and that is really, really good. And I will only mark 2 of these thingies. There are lots of different reviews here. I checked the dead code review and the programming rules review, because that are the most useful in my personal opinion. And now I run this and I can already zoom in. Yeah, oh, it's better on your screen than on mine. Yeah, some of the hints are in German. Funktion muss Rückgabewert haben. That is the same as function needs to have a return value, what Rubber Duck pointed out. The parameter ID is not used. That is basically the same. In here, yeah, I got a parameter ID, I'm not using it, so probably it's obsolete or can be removed. And there are lots of these reviews, and I can kind of expand these on, let's kind of collapse all now. I see all the forms here, and I can expand this bit by bit on method level, and then it is kind of drilling down, and you see stuff that is kind of yeah, marked by MZ tools. And these rules, you can define them themselves. Here's a large configuration area. I will zoom in a second. Here are programming rules. So, and this is the method needs to have, a function needs to have a return value. And this check is implemented with a regular expression. I can enter regular expressions and have predefined variables like the code element name. The code element name here is the method name in this case, but it could also on other level be the class name or the module name or whatever. And I can write regular expressions to define really complex rules, but it's much easier to define like simple rules. This one is a very simple rule. Classes must contain option explicit, and I simply say code. That is a predefined property in MZ tool. The code of a module must contain option explicit. Very, very basic rule, but very useful if you, for whatever reason, miss to add the option explicit yourself. So there are lots and lots of rules that are predefined with MZ tools, and you can add your own rules and really tweak it all to your liking. And there are other things in here that the indentation review, that code review, bit of code is not used, indentation review obvious. Some of the other stuff in here is not really relevant to Access because it's focused on VBA user forms, which you don't have, like the access keys review, the keyboard shortcuts and controls. That's not working in Access. But most of it is, and most of the options are very useful if you want to use them. And the best are the programming rules, as I just shown, with all those configuration options here. So, testing. We need to test our code. You all do test your code, don't you? Yeah, and of course you can test any application manually by running the UI and clicking in there and doing nasty stuff, and it should not fall apart then. But that is time consuming and tedious, and we should have some sort of automatic process to test our code, because that runs in seconds versus minutes or maybe even hours to test all the stuff manually. So this leads us to unit testing, because that is the most common form of automatic testing. Paul Rohotzka did a presentation on unit testing here 2 years ago, so I'm not going too deep here, just do a very quick summary. Unit tests verify functionality automatically. They should run fast and isolated, and they need to have a binary outcome. Either the test passed or it failed. There's nothing in between, good or not good. That should be the result, because otherwise you need to process the results in your brain. That's not good. You need to see good, not good, and all that within seconds, running automatic tests. And isolated means you should not depend on external dependencies. That is why it's called unit test. You're testing a unit in isolation. And driving that a little bit further, we are at test-driven development. And that implies you're not only writing automatic tests for your code, but you're writing the test first before you write the code. And then you implement the method. So you write a small test, you run it, it fails because you test something that does not exist. If that succeeds already, there is going to be a problem. Then you add the functionality to make the test pass. Run the test again, it should succeed now, and then you probably need to add more detail to the functionality, but you write the test first that requires that detail implementation, run the test once again, it fails, you go back to the code, add the functionality, run the test again, it succeeds, and it creates a very, very quick feedback loop that you always see, yeah, I have this tiny bit of feature, it's missing, the test fails, I add it, test completed, the feature's there, it works. And you always know your code does what you expect it to do. And another aspect of test-first development, as it's sometimes called, is you will end up with a better design, because if you focus on the test first and see your method you're going to implement soon as the client of that method using it, you get a much better idea how this should work, how the method should be implemented, which arguments and information have I got available at this moment, which can I pass in, which do I need back, and stuff. And that leads quite often to much better design. So, how can we do unit tests in Access and VBA? Testing is hard with Access, because the database is hard to test. It depends on some data being there already, or you're writing to the database and you verify the data is there, but then you change the database. So the test is not repeatable. You need to add additional code to set up your test, to create the data your test requires, or afterwards delete the data your test has written. So that is a bit hard, and it's not really so isolated because you already have code and database combined. Another thing that is hard to test is the user interface. It's nearly impossible to simulate a user clicking in the UI and entering data in there. That's really, really hard to do. And Access is a tool that is very powerful and a very rapid tool when you just glue data to the user interface. And then there is nothing in between that allows you to test it. So that is a difficult situation. And I haven't got a real solution for it. But there are still lots of things in VBA and in your VBA projects that are easy to test. Like methods that are not immediately reading and writing data, or are only reading and writing very limited data. Well, already, as I said, creates more effort, but it's still possible. And if you have classes that implement logic, which are independent of the UI or Access, then you can test that. But at least keep test code you written anyway. And I'll explain what that means. I frequently, if I write complicated methods, let's make that even bigger because the code above does not really matter. You remember the small add subtract methods. If I write complicated methods, I usually do things like that in the immediate pane to test the code. And then I would do different tests for like different situations. So I would subtract or use add with a negative number or with 2 negative numbers, and then I see, yeah, looks good. I tested all the different use cases I had in mind, looks good, and I close the immediate pane and throw that away. Of course, for an add function, maybe, yeah, we don't need much of a test, but just let's assume that is a more complicated function, and then we should keep this test code we wrote here anyway. And sometimes, if it's a more complicated thing, I need to write a short method to actually test the code. And that is something that we should keep in our code for future reference. And now I'm using the Test Explorer feature of Rubberduck VBA. And I've got a test module in here already. But it's very easy to create your own test module. Here is a menu item, you just click test module and it will create a new module in your application, and then you can add a test method, and then you end up with something like this here, which is essentially what I had in the immediate pane down here. I check for r equal 4, and the hash mark here is to define in code this is a double. That is something I haven't yet figured out. Rubberduck complains about different types, so if I would just write 4, it would be a long type, and the add method returns a double. So now I can just run my code from the Test Explorer, and I run all tests, and now I've got the green check mark here, and and the tests passed. So, and that is one way to test it, and just that you see there are multiple different tests, or testing tools rather, testing frameworks. That was Rubberduck, and it has a bit of tendency to hang some way during that process. Most of the time it works, sometimes it hangs. Therefore, I did not do that really live, but prepared it. And here is another test I prepared for another test framework. And that is something I can easily do from scratch. I create a new class module. I name that, oh yeah, something's hanging here, and I guess that is Rubberduck VBA. Okay, let's kill that off. That is a shame, because I like the ideas behind Rubberduck, and I like what they do, their approach, the open source stuff, and all about it, but it does not really work so well yet. So, as I said, keep an eye on Rubberduck, but don't invest too much time to get started with it, because it has lots of troubles, and I'm going to kind of unload it to prevent further problems. So what I wanted to do is create a new class module, name that just test defcon, and then I can add a public sub test something, and append an X, because I think I had something similar before. It's not completely intuitive, because for reasons I will explain in a second, I need to pass in an object. That is what I need to know. And then I can just do stuff like assert a test condition. That is the core essence in unit tests. You would usually do like arrange, you prepare the test, act, do something, and finally assert, evaluate the results. But I'm going to cut the first bits out and just do a quick test here. That is just a comment describing what I'm doing, and now I can call my subtract method and say, yeah, I have 10 and I want to subtract 5, and that should equal 5. So that is a Boolean expression here, and that is basically the essence of the test. If that is 5 equals subtract 10 minus 5, it passes, otherwise it doesn't. And now I've got a tiny, let's improve the name, we just name that test subtract. I compile my code and now I run a tiny add-in. That is a unit testing framework originally developed by Andre Minhorst. It's called Access Unit. And that is actually developed in Access and VBA. The code is open source. The links will be in my presentation. And what you are seeing here is a bit of an extension to that project, what I did. And it can run as an add-in. And now I've got my tests. And that is a bit of an issue. It sometimes complains about compiling. I haven't figured out how to fix that, but you need to compile. And now I've got this big red bar because here is a test that failed. Test basics. I see something's amiss. So I go to, where was it? Test something, test basics. Here we are. And this test is not working, and I'm too busy at the moment to really fix it, so I just delete it and run my tests again. And now you see I've got a green bar and all the tests run there, and I can add some more information and it will include the comments, and that way I have a easy possibility to run test code here. And you see the results. The orange stuff is warnings. The setup and tear down methods that are methods in the most used unit test frameworks to set up stuff before a test and tear down to clean up after them, and they are by definition called before and after each test. Not going into too much detail, that's just boring. The important thing is the bar is green. That is what I'm after here. The big green bar. Everything, and then about 10 to 15 tests in here, and they run in a split second. And that gives me feedback my code works as intended. So, okay, and I named my thingy access unit fork because it is derived from the original access unit. The source code will be available, and it will be, you can all download it. It will be open source as well. So,
just a quick question: why didn't you use ACK-Unit by Josef Pötzl? Does it have problems for you? Because it's a well-known framework.
Yes, it is. I wonder. There should be information in the slides, but I kind of missed it. ACK-Unit is probably the most mature unit testing framework. It's written by Josef Pötzl. It's open source as well. The links are in the slides as well, but I don't use it because it depends on a VB testing framework called Simply VB Unit, and that is, I'm not sure if it's maintained, but Access Unit uses an old version of that framework as a requirement. So you need to install that old version to install ACK-Unit, and I discarded that completely because I needed to run these tests at a client and I'm not allowed to install anything there. And it is a pain to get stuff installed. So I used the Access-based solution by André Nienhorst and built and extended upon that. So sometimes if you read about automatic testing, you will see unit tests on one hand and integration tests on the other. That is basically the same thing but with a different scope. The unit test is isolated without dependencies, and the integration test is implementing the same concept with multiple units combined. So if you have a database function, you explicitly include the database in the test. Or if you have multiple dependent objects, you will test them together. And then it is an integration test to test if the individual units integrate well with each other. The basic concept is essentially the same. So I'm not going to show that in more detail. Oh yes, and that is the slide I was waiting for. These are a couple of unit testing tools or frameworks for Access, and I already named them, so we can probably skip over that very quickly. UI automation tests. There are lots of tools that claim they can help you testing your software and verifying functionality by UI automation. Yeah, they don't work with Access. Access is a special kind of beast because you don't have real windows. Your controls are not real windows, they're just painted on the screen. Only the active control is a window. And most UI automation tools depend on controls being windows to kind of deal with them. And even if you can work with UI automation, it's really, really time consuming to create and maintain those tests. They break easily, and I've done a couple of coded UI tests for my product Ivacy, and I need to sit in front of the screen and watch the automatic testing process do its thing, because a form might show up too late and the UI automation already clicked there where the form was supposed to be but wasn't. And well, let's cut this short. UI automation with Access, it does not work, unfortunately. Another important topic, I've spoken about this quite a bit, source code control. If you ask me, you have to use source code control, but I'll keep this short. An important aspect regarding code quality and source code control is it separates the metadata out of the code. That is what some people try to include in the procedure headers. Who wrote this? When did he do it? When was it changed? Who changed it? Why was it changed and stuff? And if you really record that in the procedure header, it's going to be a long procedure header. And I guarantee you there will be changes that get missed. So if you really are interested in that kind of information, you need to have source code control. And it will not just tell you what has changed in the opinion of the developer, but you can really easily do diffs and see every single character that was changed in a source file at any given time or with any given checking.
Could we have a quick count who uses source code control here?
What's that?
Who uses source code control in this project here? That's the usual.
8 I counted. Not too many, but it's not entirely new. And if you work in a team, you absolutely have to have source code control, because it is the single source of truth in a team project. If developers tell, yeah, I fixed that bug, I have the code on my machine, it's working, it's fabulous, it will solve all the problems in the world, but I have not yet checked it in. As far as I'm concerned, this code does not exist. Once it's in the repository and it can be executed by everyone, yeah, we can talk about it. But before that, it does not exist. And that is really important to keep the code in one central location. And one thing particularly interesting today is source code control can be used as the base for automated processes. If you're a single developer, you could do that on your local disk, but if you are distributed or working on different locations and stuff, you need to have a central location that is the base for automated processes. What kind of automated processes am I talking about here? Continuous integration or continuous delivery. Yes, please?
Short question. Which tools do you use for the source control and access? Because access is a file. How do you extract the code and the source control?
I created an add-in for that. That is available as a commercial product. Thank you for asking. I thought everybody was aware about that because I talked about that a couple of times and I did not want to kind of promote my stuff enough.
Promote or throw some licenses into the audience.
No, I don't have licenses to throw at the moment. It's called Iversy, and Google that or come to me later. We can talk about that. But there was a source code control add-in from Microsoft before that was working until Access 2010. So yes, the source code control repository as basis for continuous integration and delivery. Continuous integration means you automatically build a new version of your product, not for deployment, but just to verify all the source files can be merged together into a really executable application that does actually compile. That is the idea behind continuous integration. And then you can, of course, verify the functionality of that file, but it's not yet intended to be deployed to users. That's just for internal quality control that you can integrate continuously. Each check-in that any developer makes, that any change that is made to the product should still allow the product to compile, and all quality tests that you may have implemented should still work. That is continuous integration. And if you put that one step further, then we are at continuous delivery. Then this automatically created version of your application, of your software, is automatically delivered to at least a test area where real humans test with it, and maybe even with some sort of quality control process integrated, maybe even automatically delivered to production after certain testing and quality control measurements were taken care of. The core stuff for that, or the core tools for that, are build servers. And there are a couple of build servers available, like Jenkins and I forgot. There are lots of them. And they are standard tools. They include standard processes and stuff to build most type of softwares. Unfortunately, Microsoft Access is not most types of software in the continuous integration context. So if you want to automatically build an Access application, you need to write your own build scripts that kind of implement that build process, like pull the most recent stuff from the source code control repository, create a compiled ADE file if you want that, or just make sure the code compiles in an ACCDB or whatever, and then run your quality control and deployments on that file. So, quality control. I showed you the review quality feature of MZ Tools. And the developer of MZ Tools, Carlos Quintero, he is a great guy, and he just buy his stuff. I can't explain enough, but buy it, and he even implemented, after I nagged him a little bit, an automation feature for MZ Tools that's officially documented. You can automate the review quality feature I showed you earlier in MZ Tools. And let's look into my email. And I hope there is something I want to show you. That's just in case it does not properly update here. Oh, here we are. So this has been generated today at 10 o'clock. That was while I was standing here. This email was sent, and the subject is code quality auto review. And if you paid attention earlier to my urgent fix, I had to check in, and I was promising to fix later, just to make sure I don't forget to really fix it. I created a process that pulls every change from our source control repository and runs MZTools review quality against this check-in, and if there are any results coming up, they will be merged into an email and emailed to the person who checked in that code. And this is kind of the summary of the problems that were automatically detected with my code that I checked in earlier. And I get this by email so that I can't say, oh, I totally forgot about that. So I at least have the reminder. Of course, I still can ignore it, but I can't really say, yeah, I did not know. Because that is actually a real problem. I tell people I work with, and myself included, please do run the review quality feature of MZTools before checking in stuff. But as it so happens, like I'm in a real hurry, I need to check in, I forgot to review quality. So I created this automatic process to make it impossible to forget it. And I'm quite, I love it, because I used to be the bad guy in the projects, telling the developers, oh, you did this and that, and I don't like it, please fix it. And a week after that, I need to repeat the same stuff again, and I hate it. I don't want to tell people that all the time. So I created this automatic process that the people are nagged about these issues automatically. And I don't need to do that. So unfortunately, the only real tool that is available that does this kind of automation, oh, excuse me, that was wrong here. So, unfortunately, the only tool I'm aware of that can be used for such code quality review and that can be automated is MZTools. If you want to put in a lot of effort, you could take the RubberDuck source code and build your own validation process. And that is actually probably an even better approach, because they are really parsing the VBA code independently. But it will be a lot of work, and I'm not really suggesting that to any of you unless you want to really create a common tool for that. It's too much work to do for just one project or for your own work. So, what about automating unit tests? I originally intended to show you the same bit like the review quality here for automatic unit tests that are also run after each check-in. But I was not able yet to implement it. It definitely should be possible, and it should not be too hard. I just did not find the time to do it. The ACC unit testing framework that can, the slide read, it should be possible. It can. The developer confirmed it can be automated. But a bit of a problem remains. It's only really sparsely documented. I think there is a sample. He posted a sample after I asked him. It's 3 lines. Yeah, you did this, that, and that, and then you can do all the automation stuff you want to do. Yeah, it works. I believe him. That is not a question. But it's you need to do a bit of research and try and error and stuff to work out how it works. RubberDuck cannot be automated, that's just an UI tool, but the source code is available. As I said, you could do some stuff yourself. Access unit cannot be automated as well, but my fork version, the thing why I especially what I especially try to enhance and improve is automation features, that unit tests can be run in an automated process and create automatic output. So, everything I spoke about here up until now was about VBA and Access and maybe a bit of similar languages, but mostly VBA. We have another language that we deal with regularly, SQL or T-SQL, the SQL Server programming language. So what about that? The situation is different there, and most of the stuff I said only applies to VBA code. Because in SQL, it's much harder to use functions. In Access, not too bad. In SQL Server, if you use too much functions in your views, in your select statements and stuff, it will degrade performance. Even if you are careful not to kind of prevent the searchability, the index usage of the queries and stuff, even if you pay attention to that, and only kind of move simple calculations or stuff from the SQL, like in a case statement or in the column list or wherever, and move that to a function and call the function instead, it will significantly degrade performance. However, that is something that Microsoft is particularly addressing with SQL Server 2019. And people who had seen earlier releases and previews and say, yeah, that hugely improved. So there the situation is changing. So that rules out that we create named methods, that we isolate functionality. So in SQL we still have huge blocks of code. That makes formatting the code in a readable way even more important. And comments here are more useful because you have less options to make your code more readable. Of course, you still can use functions and views. Whenever there is a legitimate reason from the functionality side, still use them. Don't misunderstand me that I say you can't use functions. But they actually might slow things down, so don't use it just to name things, as I showed it in Access. And well, yeah, set comments may be more useful. Unfortunately, in Access, SQL, View, or Access queries, yeah, you don't have any comments, but well, there's nothing we can do about yet. Okay, that is basically the end of my presentation. So I just want to address you and say thank you, and I've got one big thing to ask you, and I say you are all professionals, professional developers. Please take care of the quality of your source code.